Hello everyone, welcome back to lesson number 7 for Calculus AB. This is going to be our derivative rules. We've talked about the power rule, we've talked about the product rule, and now we're going to talk about the quotient rule. So the quotient rule sounds exactly what it means. We have a quotient, which means we have a fraction, and a fraction where we cannot simplify. So let's go ahead and to say what the quotient rule is, and then we're going to show you a couple of examples. So if I want to find the derivative of h of x, and the function h of x is just the quotient of f of x divided by g of x, where we're assuming that g of x does not equal 0. Then what we're going to do is this. We're going to go ahead and take the denominator, and we're going to write it out. So we're going to keep our denominator, and then we're going to multiply by the derivative of our numerator. And so I tell students that because quotient rule, the order does matter. So remember, product rule, we just had to do first times derivative second plus the second times derivative first. It doesn't matter which one goes first as long as we have both terms in here. This one does matter. So we have our denominator times the derivative of our numerator. So since this is an order, it's a little bit more time consuming, so it's a negative experience versus the product rule. So we do a minus, and then we're going to do the first, the numerator, times the derivative of the denominator. And we're going to do all over your denominator squared. So there's a little saying that we do with this. So we consider, and that's my little saying here, we're going to call this our high, and this is going to be our low, right? I know I didn't spell it right, I know, but it's high, low, just trust me on this. So this is high and low. I know if people are bothered by that, but I'm going to call this high, and this is going to be our low. But anyway, so this is going to be low, d high, so derivative of high. So low, d high, minus, and I like this one because this actually says a name. So high, d low. So high d low. I always say, here's our girl, high d low. So low d high minus high d low, high, top, derivative of low, all over low, low. Right? So high d low got low, low. So low d high minus high d low over low, low. And it's kind of how you do it. So we start low, we bring it down, right? We start low, get high, so low d high minus our girl high d low all over low low. All right, so that's the quotient rule. So let's go and do examples. So in the notes, you guys can see that the quotient rule is right here for us. So if we're taking the derivative of a function f over g, this is what I just wrote on the paper beforehand. It's going to be your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. And that's exactly what you see with the different notation. And then here is our little song. I'm not going to sing it, don't worry about it, but it's going to be low d high minus high d low over low low. Okay, low low. So that's what we're going to do with this. This is the high d ho one, and this is the high low one. So I like this one a little bit better. But ho d high minus high d ho over ho ho is also one that you guys could learn. But I like this one because we got our girl high d low over low low here. So let's actually talk about the quotient rule and apply it. Now, ladies and gentlemen, this is so done with the power rule. I mean, you want to immediately, if you see this question, you want to rewrite it like this and use the power rule. So we're going to find the power rule derivative first. So using this, I'm going to move the negative 2 down and multiply times 3. So this is going to be negative 6. X, be careful, be careful, be careful. It's to the 1 less power, right? So it's negative 2 minus, it's negative 2 minus 1. So our derivative is going to be negative 6x to the negative 3. And remember, this negative is only on the x. So our derivative is going to be negative 6 over x cubed. So this is the answer that we will get when we implement the quotient rule to this problem. And this is actually not hard because one of our functions is actually a constant. So if I do the question, if I want to do the question here, then I'm going to go ahead and I'm going to call 3 our f of x, and I'm going to call x squared g of x. And we want to find the derivative of y. So we're going to do the derivative of y. So again, we got low, we start low, and then we're going to multiply by the derivative of our high. So the derivative of a constant is just going to be 0. Minus our girl high, d low, right? Derivative of low. So high times the derivative of our denominator, all over low, low. So over low, low. And just let's simplify this down. So we're going to get, this is becoming 0. So this is going to be minus 6x on the top, right? Minus 6x on the top. and the bottom's going to be x to the fourth. And then if I want to simplify this down a little bit, I'm going to take out an x in both of them. And we, sure enough, get the answer choice that we have over there. Okay, so that's it. That's all that we do with the quotient rule. So I'm going to look at a strategy problem right now. And this says, consider the function y equals x squared plus 1 over x. We're going to go ahead and do it the quotient rule way. And then we're going to do a strategy way. Okay, the strategy way, and hopefully you guys, when you're seeing this, you can figure out something I can do to make our derivative a little bit easier. But we're here to practice the quotient rule, so we're going to do the quotient rule first. But again, in these videos, I'm going to show you guys there's other ways to do this where the quotient rule is probably not the best way to do it. But let's go ahead and do the quotient rule. And so we're going to go ahead and find the derivative of our function x squared plus 1 all over x. So we're going to start out with our low, right? So it's going to be low times the derivative of our high. Well, the derivative of x squared is going to be 2x. Derivative of a constant is just 0, so it's going to be low d high minus high, good old high d low, derivative of low, all over low. Okay, over low. And I know as a calculus student, you know not to cancel this x squared with this x squared, right? You have to do it for all of the terms. So let's go ahead and do that and just simplify our function down more. So I just multiply these together, and then I distribute the negative. And so I'm left with y squared is equal to positive x squared minus 1 over x squared. Okay, so here is our derivative. Here's our derivative. And so hopefully for some of you guys, you already know what the strategy is I'm talking about for this is I want to simplify this first. Before I actually take its derivative. And what we can do here is we can split up the numerator. We can rewrite this as x squared over x plus 1 over x. If I were to actually add these fractions together, we'd get back down to this. So I can now simplify this even more and get that the function y is equal to x plus x to the negative 1 power. And then all we have to do is our fun rule, the power rule. So we don't have to do this crazy quotient rule stuff. All right, so let's try this and make sure that we get this answer right here. So we're going to do the derivative of our function. So the derivative of x is just going to be 1 plus, we're going to take negative 1 and move it down in front of the x. So we're going to get negative 1 x to the 1 less power. And so we're going to get that the derivative is going to be equal to 1 minus 1 over x squared. And we look at these and we compare them. They may not look the same, but they definitely are, because we can now split our numerator like we did here, and we can get that this is x squared over x squared minus 1 over x squared. And then, ladies and gentlemen, we're now back to 1 minus 1 over x squared. Okay, so sometimes just because the function is a rational function does not mean that you have to use the quotient rule. Okay, doesn't mean you have to use the quotient rule. So hopefully that is making sense. So let's do one more example of the quotient rule and see if you guys are okay with it. Okay, so for example number 10, this is a great example where we finally can't simplify. Like, we actually have to use the quotient rule. So this is the very first example where you actually have to use the quotient rule. It has to be the quotient rule. Okay, so let's incorporate it and let's do it. So y prime is going to be equal to, well, our denominator is going to be the first thing that we write on our paper. So 3x plus 2. Then we're going to multiply by the derivative of our numerator. So again, it's low d high, which is just going to be 2, minus our numerator, 2x minus 1, times the derivative of our denominator, which is going to be 3, all over our denominator squared. Now, when you are simplifying this, now again, if it's an FRQ free response question, you leave it just like this. But they're going to usually be simplified multiple choice questions. So when you do simplify, I'm going to tell all of you right now, never ever do anything in the bottom. Just leave it be. Just leave it be. So we're going to go ahead and distribute the 2, and we're going to get 6x plus 4. Be careful with your sign here. So we're distributing a negative 3 here, right? Negative 3. So negative 3 times 2x is going to be negative 6x. And then we're going to do negative 3 times times 1, negative 1, is going to give us a positive 3. Okay, positive 3. And so this simplifies down to, well, the 6x's cancel. Boom, boom. And so now we're left with 7 over x squared plus 2 squared. And this is going to be the answer that you're going to see on your multiple choice question for the quotient rule. Okay? So that is that example. What I want to do to finish up is just tie all the videos in, as I usually try to do, with one more example. So let's go ahead and look at it. So this last example is going to be pretty much just solidifying what we just did in the first 3 videos. Okay, so it says the derivative of f of x plus g of x. Well, this goes back to the power rule. You can simply just add the derivatives independently. Okay, so it would be f of, and we're assuming that we're looking at x equals 0 for these problems, because that's what it looks like up here. They're all at 0. So f prime of 0 plus g prime of 0 is just going to give us 2 minus 1, which is going to give us 1. So this answer right here is going to be 1. The derivative of f of x plus g of x is equal to positive 1. For the second one, the derivative of 2 f of x. So I'm going to just very quickly show you guys the reason why. So the derivative of 2 f of x is really just 2 times f prime of x. And the reason why is if you use the product rule, because we do have 2 functions multiplied together here. So if y is equal to 2f of x, and I use the product rule, which was what we should do, right? We take the first times the derivative of the second plus the second times the derivative of the first. Well, the derivative of the first is 0. So the derivative of all constants is going to be 0. Therefore, you never, ever have to use that. And this was actually one of the rules that was in the very first video that I don't think I actually went over with you. So that is why. Because I hadn't talked about the product rule yet to prove that. So I can show you guys that in 1 second. But 2 f of x, f prime of x, minus 3 times g prime of x. That's all that you do for this problem. And then we're going to evaluate that. I'm going to erase all that stuff there. So we get 2. And again, we're going to apply f prime of 0, which is going to be 2, minus 3 times plug in g prime, which means negative 1, which is going to give us 4 plus 3, which is going to give us 7. Okay, that's going to give us 7. So the answer is 7. Now part C, you see this. You do not, does not equal f of x, f prime of x times g prime of x. You have to use the product rule here. And students forget that. You have to use the product rule here. So the derivative of this, the derivative dy dx, is going to be equal to f. By the way, and I know you guys know this, but f of x times x is just the same thing as f of x times g of x. Okay, they're written, that's the same thing. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. Again, remember, product rule plus. So f of 0 is 3. G prime of 0 is going to be negative 1. Plus g of 0 is going to be 4 times f prime of 0, which is going to give us 2. So this is going to give us negative 3 plus 8, which is going to give us a positive 5. So just be careful with this question right here, because again, we're using the product rule. So likewise, ladies and gentlemen, on the last example, we're going to do the derivative of f of x over g of x. You have to use the quotient rule. You have to use the quotient rule. So this derivative, dy dx, is going to be equal to your denominator times the derivative of your numerator minus, because quotient is negative, your numerator times the derivative of your denominator all over your denominator squared. And so let's just start plugging in our values. If we can find them up there. Okay, so cool. So the denominator, g of x, g of 0, is just going to be 4. So we're going to square that. We're going to get 16. And then g of x is just going to be 4. I don't know why I had to look that up. We just found it right there. F prime of 0 is going to be 2 minus f of 0 is 3. And finally, g prime is going to be -1. And, like I said, if this was an FRQ, ladies and gentlemen, I would 100% keep it simple and not simplified. But if we are looking at actually multiple choice here, we're going to get 8 plus 3 over 16. So this answer is going to be 11 over 16. So that's going to be our derivative for this problem. So, okay, ladies and gentlemen, that is it. I will just show you guys really quickly that what I was talking about right here, example B, was right here in this constant multiple rule right here. So if you're trying to take the derivative of a constant times f of x, it's just going to be that constant times f prime of x. And again, that's derived from the product rule. So that is lesson number 7, derivative of our functions for the power rule, the product rule, and the quotient rule. So we're going to come back in lesson number 8, and we're going to learn the most famous one, the one you're going to use the most throughout this entire course, our good friend, the chain rule. So hopefully you guys thought this video was helpful, and I will see you in the next video.